On 18, what times what would give me negative 135? Guys, like I gave you 15 minutes. What times what would give you negative 135? 18 and what? 15 is 15 and 9. Okay. And one of these has to be negative, right? What about the next one? Negative 104. 13 and negative 8. Negative 28. 14 and negative 2. Yes. Which one?
Because 5 times 7 is 35.
Okay. Do y'all agree or disagree? So if we take 15, we multiply it times 7, that gives me 105. If we take 15 and multiply it times 9, we get 135. So this should be 9. What times what would give me 120? Wait, hold on. 12 and 10. Does that add together to get me 23? Nope. How can we go about solving that one? We could go into Desmos. And we could type 120 divided by x. We could go into the little table. Okay. Are there any of these numbers that I can add together to get you 23? No. Look again. What about 8 and 15? Does that work? What about the next one? What times what would give me negative 10, but add together to get me 9? Negative 1 and 10. And then what times what would give me 4, but add together to give me negative 5? Negative 4 and negative 1. We have talked about linear, quadratic, and exponential. Okay, so with linear, we're going to find our first difference. So what's 6 minus 3? 3. What's 9 minus 6? And 9, I'm sorry, 12 minus 9. So notice how all of these are the same. So that means that our first difference is the same. That makes it linear. An example of this is going to be y equals 4x. So with quadratics, what's 6 minus 3? 10 minus 6? 4. 15 minus 10? 4. So these aren't the same. So then if I subtract them again, what's 4 minus 3? 5 minus 4? Notice how these are the same. So the second difference is the same. An example of this would be something like y equals 4x to the second power. On the next one, if I find the first difference, that's 3, 6, 12. If I do it again, I get 3, 6. Neither one of these is the same, right? So we're going to look at and see if there's a common ratio that it's being multiplied by in order to make sure that we're exponential. Well, what are we multiplying by each time? 2. So since there is a ratio of 2, that makes it exponential. An example of this would be something like y equals 2 times 4 raised to the x. Okay, so coming down here. Yeah. So that's going to mean that the first difference, up here, first difference are not the same, but the differences between those values are the same. Things we want to remember from this is second difference is quadratic. All right. So now we're going to have 10 minus 6, which is 4. 14 minus 10 is 4. We see that the second difference is the same. So that's going to be a what? Quadratic. Yep. I don't know what you changed. Right. On the next one, we got -6. Then we got -8. Then we got -10. The difference between these is 2. So that's going to be a quadratic. The last one, 14 minus 20 is -6. 8 minus 14 is -6. And 2 minus 8 is -6. All of these are the same. So that's going to be linear. Okay, so which of the 4 relationships will have the greatest y value when x is 5? So when x is 5, these two. Yes. Yep, go. Okay. So, are you ready? Okay. When x is 5, your y is 14 for these two. Okay. So if we go up here, so the first two, remember how this one was multiplying by 3 each time? If we multiply by 3 until we get to x equals 5, we would have 243. That's going to be the highest because it's exponential and it's growing faster, going up at a faster rate. So it's going to be the exponential because it's multiplied by 3. We're going to use symmetry and constant second difference to complete the table and graph for this rocket. So for the first difference on this, we got 52 minus 0, which would be 52. 94 minus 52 is what? 42. 126 minus 94 is what? Okay. If we find the second difference, we see that there is a difference of 10 on both of these. In order to complete the table, and this is the part that it gets a little tricky on, so pay attention. This is going down by 10. The difference between this number and this number is going to be 22 because the difference between these two is 10. So 126 plus 22 is going to give us 148. We're going to repeat that process again. The difference between this number and the next one has to be 10, so that's going to be 12. And that's going to be 160. So I'm going to graph those two pieces really quick. Okay. I'm going to do it one more time because we're going to need the other half of the graph. So the difference between these two is going to be 2. So that's going to be 162. And then the difference between these two is going to be -8. Okay, so -8 is going to be what? 154. Right in here. Okay, so this little graph is going up and then it's going back down, right? So with that being said, here are the other dots that you can just fill in. So we've got 8 comma, I think it's 148. This one, and then this one. So how did I fill that in so quickly? It's not math magic. So I didn't fill in the chart for the rest of it, right? What happens with quadratics is right here, there's a line of symmetry. So if something happens on the left-hand side, it's going to happen on the right-hand side. This should be a little closer. Okay, so it's going to be a reflection across that line. Okay, The graph of the quadratic relationships have a line of symmetry that is a line that if you fold the parabola, and that's what we call the little like U-shaped graph, along the line, then it has two identical halves. Okay, so the line that if you fold the parabola along that line, then it has two identical halves. Okay. So it says draw the line of symmetry. Okay, so this is going to be right here at x equals 5. And then it says plot the points on the graph and list them below. So the points right here or right here are on the graph as well. So that was 628 and then 220. Okay, which water balloon went higher? A or B? A, why A? It went up to 30 and this one only went up to 29. So A went to 30 and B went to 29.